Welcome to this OpenText connector session. The agenda for today is as follows. First, I will say a few words about the Xillio company. Then we continue with the content ETL platform developed by Xillio. And we look into important market demands concerning the OpenText connector. Further, I will present an overview of the migration process, the choices made regarding the available APIs, the implemented features, performance results, and the presentation will be concluded with a migration process demo to the OpenText Content Server. Xillio was founded in 2004 and for 10 years specializes in content analysis, deduplication, classification, and content migration. Xillio forms partnership with a number of other companies. For example, I am a Capgemini employee myself, and in collaboration with the Xillio team, we have built the OpenText importer that I am presenting today. The main software product of Xillio is the content ETL platform, which is designed to facilitate content migration processes. The content ETL platform is structured in several layers. The first layer of the content ETL platform is the Xillio IDE. The automation of migration processes is achieved through scripting in Xillio IDE, and a connector is an example of scripting. A connector is a reusable and standardized interface for importing and exporting data from various sources such as the OpenText Content Server. The next layer in the content ETL platform is the Unified Data Model, or shortly UDM. UDM is a concept elaborated within Xillio that provides great benefits for usability and standardization of the migration process. The platform is also augmented with a series of modules. For example, the classifier for document classification, the duplicator for version identification, the file share package for generation of insightful reports to visualize migration results. When we have started with the development of the OpenText connector, we did some research on the market demands. The first demand is to support an automated migration process. Migrations that rely on manual operations are error-prone, take longer to execute, and are difficult to control. On the other hand, an automated migration process is easier to monitor, less error-prone, and thus more accurate. Another demand is scalability. It should be possible to leverage additional software-hardware infrastructure to improve performance if needed. The migration process has to be traceable. One should be in control of what is happening during the migration. So, for example, information like how many files have been migrated, how many files are still on hold and waiting to be loaded, how many files failed to be imported, must be made available during the migration. Further, migration software that is self-contained is preferred over software that requires additional external modules. It is also critical to employ only approved API to communicate with the OpenText Content Server. It must be possible to add migration-specific requirements with minimum scripting, and insightful logging of the migration process must be provided. Well, we believe we managed to cover all the aspects in our implementation. Next, let me present an overview of the migration process from a source system to the OpenText Content Server. In the considered migration, content is being extracted from a source system and is being imported to the OpenText Content Server. Then we have thought of a data representation that all the systems will have in common, the UDM standard. The UDM standard can be used as is in all migration projects without requiring any changes. Then we have added the connector. The connector is the communication interface between Xillio core and the content servers. The connector, together with the UDM standard, contain code that is valid independent of the migration project. The UDM contains also a custom part. This part includes features that are specific for the source and/or the target system. The communication with the UDM usually requires a mapping. That is because the source system, for example, provides content types in a specific format. To store these content types to UDM, a mapping is required that would transform the content types into the correct UDM representation. And the same holds for the import. Furthermore, extra information may be provided. And let me give you an example. Let's consider a migration from file share to OpenText. From file share, it is not possible to extract information regarding versions, categories, or permissions. However, such information may be provided separately. In that case, one can easily integrate the provided information in the migration process. Per project, there might be variations in requirements. Requirements can be modeled as business rules and introduced in the migration process, either before loading to UDM or immediately before importing to the OpenText Content Server. Now I would like to talk a little about the path we took and the choices we've made regarding the available OpenText APIs. One possibility to import documents to the OpenText Content Server is by using the OpenText Object Importer. We did not use it for our connector since it is a separate OpenText module. Another possibility is via the XML import. We have actually started building the connector with the XML import. However, it turned out that the XML import is not suitable for parallel import of documents with a hierarchical structure and thus not scalable. That is why we continued looking for yet another API. With the REST API, we have implemented the most of the functionality, but the REST API is not yet complete. It does not contain all the features one would like to have. Therefore, we had to use also the content web services to compensate for some of the missing functionality. Finally, there is yet another way to access OpenText features with the screen scraping. And that is a solution we would employ only in exceptional cases, only when all other available methods are not applicable. This slide summarizes the most important features supported by the OpenText connector: categories and attributes, versions, users and groups, to name a few. You can notice we have used the Content Web Services API to be able to import permissions. Apart from that, it is also possible to migrate from systems that are hierarchically structured. Special characters and file names are also handled, and I will show you this functionality in the demo. There is also possible to migrate files which contain more than 256 characters in their name, files that have long names. At any point during the migration, one can get an overview of how the migration evolves. For example, 200,000 files have been already migrated and 100,000 files are still waiting to be loaded. Logging and exception handling is also done. For instance, it can be easily identified what documents fail to be migrated. Resume functionality is also available for the OpenText import. The resume functionality covers two scenarios. First, when a number of files have failed, only the failed files are migrated when restarting the migration process. Second, when the migration has stopped for a particular reason, for example, a network failure, well, in that case, the migration starts with importing the remaining files. So, if for instance 100,000 files were loaded and there are still 200,000 left, then the migration starts with importing the remaining 200,000 files left. So far, you've seen how we've modeled the migration process, what APIs we have used, and what functionality we have implemented. But we have also focused on improving the OpenText import performance. We have started with one OpenText Content Server and one server to run Xillio. So, at the beginning, we have built the OpenText importer as a single-threaded application where only one request was sent from Xillio to the OpenText Content Server at a time. The request traveled through the communication channel to the OpenText Content Server. The Content Server was processing the request and sending the result of the processed request back to Xillio. To speed up the process, we started to send multiple requests to the OpenText Content Server in parallel. The OpenText Content Server was processing a request and then immediately continuing with the next one, not being affected by network delays. That had a significant impact on performance. However, when too many requests are sent simultaneously, the OpenText Content Server can get cluttered with requests and is not able to process them fast enough. To solve this issue, a new OpenText Content Server can be added to mirror the first one. The import is done to both servers at the same time, which further improves the throughput. At that point, it can be that Xillio does not send enough requests to both the content servers. To compensate for this, the setup can be easily extended with multiple Xillio instances. The performance tests that we have run so far were conducted on the following dataset. A randomly generated file share structure which contains uniformly distributed folders and files of different formats, for example, executables, PDFs, or Office files. The folder structure consists of up to 20 subfolders and 100 files per folder, with a file size between 1 kilobyte and 2.3 megabytes, and an average file size of 220 kilobytes. Further, the main characteristics of the computers running the Xillio IDE and the OpenText Content Servers are provided. Note that the OpenText Content Server was running on a virtual machine, and both machines were running on different network instances. These are the results that we have obtained. The graph you see here shows the number of imported documents to the OpenText Content Server over a certain period of time, indicated in minutes. Please notice a near linear growth of the number of documents in time. This is a very important observation because it allows to extrapolate the results. The performance of the import depends on a number of factors, such as network delays, server characteristics, migrated content, and so on. With the current setup, we have managed to import up to 100,000 documents per hour, which extrapolated means several millions per day. Before we proceed to the demo, let me give you more details on the migration process setup, which goes through the following steps. Export from a file share, export from an OpenText Content Server, load to UDM, unload from UDM, and import to the OpenText Content Server. I will also give you an example of a business rule and how easy it is to customize the code to integrate additional rules. I would like to start by showing you the tools that we are using for the migration. What you see here is the Xillio IDE where we have built our scripts, and I will start using it already to run our first export, the export from the file share. Once the first export is ready, we can continue the second one, the export from the OpenText Content Server. Except for the Xillio IDE, access to the OpenText Content Server is of course required. Further, we use the Mongo database to store the migration data, and as you can see, while exporting, the database is being populated with all kinds of documents. Also, the UDM elements such as content types and decorators are being defined. If you remember, in slide 6, we were talking about the OpenText migration process and about the UDM standard and the UDM custom. Well, lots of the UDM definitions are actually standard, so they are the same regardless of the migration system. For example, binary files. In all systems, they have, well, a name, they have a size, they have an extension. Also, in a hierarchy, there is information provided regarding the parent of a document. It is also usually known when a document has been created or when a document has been modified. And all these kinds of UDM standard characteristics are being populated at export. So if we're looking here, for instance, at this document, you can see that it has, well, a specific size, it has a path, it has a name, it has parent information, and some other types of information. For instance, the hash is also being specified. But there are also UDM custom characteristics. Let's take a look at the following document. I will be searching here for source for a file with name brand, and what this file has. This file has categories, and well, you can see here it's a category list. Actually, there is only one category, but the idea is that category is actually specific for the OpenText Content Server, and it's a part of the UDM custom. With both the extractions finished, we can start with importing to the OpenText Content Server. As mentioned in the presentation, the resume functionality has been implemented, and I will be showing you now the second scenario of the resume. That is, if the migration stops, it can just be restarted, and it will continue with importing only the files that have not yet been migrated. So let's do that. Let's stop the import, and let's start the import again. And it will just continue from where it left. What would be interesting to mention is that in Xillio one can create a settings file, and in this settings file one can specify all the required settings for the migration setup. The advantage of having such a file is that it keeps the system settings separate from the rest of the project. What is also important is that at any time during the migration one can get to know what the status of the migration is by just running this robot here. And what the robot does, it generates a document, and the document specifies how many documents have been migrated and how many documents are still to be migrated. Further in this demo, I would like to show some more of the migration features we have considered for the import. To begin with, categories and attributes are being created in the OpenText Content Server. For categories, I have implemented the business rule, and to explain what the rule does, I will go to the original OpenText Content Server export folder here, and I will be looking at the categories of the issued bill. So what the rule does, it ensures that the case number, unlike the comments field here, will be imported in a specific format. For example, that it will not contain any letters, like for instance this V letter here. And I'd like to show you this rule also in the code. The function where this rule is implemented is called the map category. And what it does, it applies a regular expression to the comments field, and it ensures that the case number is migrated in a proper format. So if we are going now to the import folder, you can see that files and folders have been are being migrated here. So we are going now to the issued bill and to the categories of the issued bill. You can see that the V letter is no longer here, so that means that the case number has been actually migrated properly. Next, permissions are also being imported. So if we are going to the permissions of the issued bill, by default all documents are being imported with assigned access. However, I have added an extra user to show that not only default permissions are set, but also special permissions are successfully migrated. Another aspect we have considered is the import of versions. So if we are going now to the Finance Beta REST, and then to the operational research, and to the versions of the operational research, You can see here a list of versions, and what we are going to do is we are going to compare the order and the sizes of these versions with the ones of the original document. So if we are going to this original export folder, finance beta, rest, and then to the version of the operational research, well, you can see that actually, well, they match. So the import is being executed properly. I have also mentioned during the presentation that folders and files with names that contain special characters and are longer than 256 characters are being imported as well. And I'm going to show it to you now. So in the beginning, when we did the export, we were exporting also these folders here and this file, that if we are trying to edit, it says that the file name is too long. And now I will show you that they have been successfully imported. So if we are going to the import folder, the file share, you'll see these folders which have long names, and then also the file which has all kinds of special characters, and you see that actually its content has been successfully imported. If you are interested to know more about the connector, please visit our support site at support.xillio.com. You'll find there the OpenText connector documentation, updates on the performance results, as well as documentation and example scripts for our connectors. Thank you for your time.